All right, intermediate algebra. Welcome to another edition of Learning Math at Muzz Math Rocking with the help of BackHall Productions. This is my backhaul. Today we're going to talk about how to solve an equation that has rational expressions. Okay. There's lots of good videos also online in the YouTube channel that it's where I'm kind of working on a piece of paper. You see my hands, but this is seeing me because some people learn a little bit better when I point and talk and so forth. Okay, so we did stuff like this earlier this year. At the very beginning of the year, we learned how to solve equations with fractions, how to clear them by multiplying by the least common denominator. So we're going to need to do that again. So I'm going to note up here that we need the LCD. The whole thing here is, unlike addition, subtraction, I don't want to keep the denominators. I want them to disappear so that I'll have a standard equation, either quadratic or linear, and I can go with my learned methods for doing that. So what's going to happen is, we're going to find the LCD. We're going to multiply each term by that. And then, miraculously, and the reason we do it is because it works beautifully, all denominators will cancel and we will have a simpler equation. So let's go about finding the LCD. Now to do that, I need to factor each denominator. I do not need to do anything to the numerators, but I'm going to leave myself lots of room, as you know. Now, both of these first two ones, the denominator was already factored. There's nothing more you can do to these. But this one, you can. Now, I never take much of a look at the numerator. I want to factor the denominator because that's what I'm looking for, is denominators. LCD stands for denominator. All right. Well, 2 and 10, I can pull a 2 out. X squared and x. So there's a GCF here. Now, what you'll notice is that the LCD is just like when we did before. If you think about it, what is he missing? Well, he doesn't have the 2x. What is he missing? Well, he doesn't have the 2 or the x plus 5. He's not missing anything here. So, as it turns out, in this case, that is the LCD. We make that list by taking everything we have. Take the biggest one you've got, the most complicated, start with that. Is everybody covered? That's my LCD. So I want to multiply everybody by this over 1. Now notice, I am not putting something in the denominator like we did with addition and subtraction. I don't want things in the denominator. I want them to go away. Now hopefully this is visible way over here. I think it is. All right. Is it legal to multiply everybody by the same thing? Yes. It's like I multiplied the left and the right-hand side. But this is a long process, and I shortcut it by not writing it here and here. Just going and putting it next to everybody. It's totally legit mathematics. Right? Some of my examples that you'll see online, I showed it up here just because I had more time. Okay, now here's why we did this. Good things happen. We're going to take everything in a denominator, and it's going to go away. By having the 1s here, we're not bringing anything new. Let's start over here. The 2x cancels. The x plus 5 cancels. So on that side, everything cancels. Over here, the x plus 5 will cancel, but not the 2x. Here, an x will cancel, but not the 2 or the x plus 5. Now, I don't think it's a good idea to do the multiplication in your head. What I'm going to do here is make the list of who's surviving. I'll do the multiplication on the next step. Minus 2x, he's a survivor, so is the x plus 3. We always use our happy parentheses. And over here, everything turned into a 1 except for the 5x minus 3, which is, if you want to, you can think about it, it's just being multiplied by 1 because everything canceled. That's why we do this. All denominators are gone. This is now an equation we did in the fall before Mr. Mazdakis disappeared. We handled these kinds of things. Now, it may turn out to be a quadratic. We'll have to see. But ultimately, I have to distribute. I have to add like terms and take a look at where we're at. Is it linear or quadratic? So let's go on here. This is a 6, as you know. 6 times x is 6x. 6 times 5 is 30. I'm distributing. Now, when you distribute this one, I strongly recommend that you think of it with the negative and do it all at once. So here we go. Negative 2x times x is minus 2x squared. Then minus 2x times 3 is minus 6x. And on this side, distributing a 1 does virtually nothing. Leaves it alone. All right, so we just found out this is a quadratic because there's an x squared. It's not going to go away. It's going to be there. So I am going to combine like terms on each side. And what I notice here is 6x minus 6x is gone. I like to write things in order like this. Okay? Now, what am I going to do here? Well, I have a negative 2x squared. Don't like that. So I'm going to head this way as I add a 2x squared to both sides. All right? I'm also going to subtract a 30. And I'm doing this together because I'm running out of room here, as you can see on my wall, and I don't really want to write down here because I don't think it'll be visible. But that gets me a 0 on this side because everything went away. A 2x squared plus 5x minus 33. It's a typical quadratic. There's no GCF, 2, 5, and 33. Nothing goes into all of them, and that doesn't have an x. So I would need to do my factoring. Now the good news is we know it's 2x and x. When it comes to 33, I have to think about 1 and 33 and 3 and 11. Those are my only choices. The 5's pretty small, so I'm not using the 33. Just makes sense. 33 is not involved. So I have the 3 and the 11. If I put the 11 here, I'll get a 22, and that's too big. So I'm going to put the 3 here and the 11 here. That's my best guess. Let's see how we're doing. 2 times 3 is 6. 11 times 1 is 11. 11 minus 6 is 5. There you go. It's because the 2 times the 3. And that needs to be positive because the 11 minus 6. Factoring's key. You could have actually turned to a quadratic formula if you're part of the quad squad and would appreciate doing it that way. So here we go. 2x plus 11 equals 0. X minus 3 equals 0. So one of our answers is x equals 3. That's a nice easy one. That does not look like an equal sign. Now it does. This one, you get 2x equals minus 11 and x equals minus 11 over 2, which is minus 5.5. We have two answers, and they both work if you do happen to go back and plug them in to check them. We're not spending checking time at home because I don't know what kind of calculators you have, so you'll have an answer key that you can actually find these and look to see how you did, all right? If you run into trouble when you're doing things, you can send me a picture of what you have, and I can respond directly in a way to help you find your error. That's still possible. If you do that during the week, I can definitely get it back to you quickly. If you wait till Friday when there's a lot of papers coming in, it might take a little bit longer. But remember, I'm taking all work as we work onwards. If you've completed last week's mixed review set and now feel like you could do more, go back and do assignments, finish them, or start them and finish them. I want to see your work. I want to give you credit, and you want to master this material. This is kind of what learning is going to be like for the rest of the year. So we really need to buckle down, all of us pitch in, and do what we can, okay? This is the back hall. This is where things happen. There's Buford's here. I'm here. My broom is here. Okay, so you need to get to it. And I wish you the best of luck solving equations with rational expressions. We're going to do this for a couple of weeks as we get good at them, and then we're going to be doing applications with work problems. So hopefully you're having fun out there. I miss you. Room 3021 misses all of us. So now I'm going to walk towards this. It's going to look a little weird because I have to turn it off. I don't have a production crew. Here we go.